Hold out your hand and look at it. That hand is about 10 centimeters across, and it is the only ruler you have ever truly understood. Every distance you have ever felt in your bones, the width of a street, the length of a flight, the span of an ocean, is built on that ruler, scaled up from the size of your own body by a brain that evolved to judge the distance to a river crossing or a fruit tree and nothing more. Tonight we are going to take that ruler and try to measure the universe with it. And I am going to be honest with you from the start. The ruler is going to break. It is going to break early, and it is going to keep breaking again and again at every single stage of this journey. Because the universe is not just bigger than you think, it is bigger than you are capable of thinking. And the honest goal of tonight is not to make you comprehend the true scale of the universe, because no human mind can, but to let you feel, at least a few times before you sleep, the exact moment when comprehension fails. That strange, dizzy sensation of the floor giving way, which is the closest any of us will ever come to grasping how big it all really is. We are going to start where you are sitting right now, and we are going to move outward, step by step, rung by rung, from your room to your planet, to the moon, to the sun, out through the solar system, past the last of the planets, through the vast invisible halo of ice at the edge of our star's influence, across the ocean of nothing to the nearest star, out through the spiral arms of our galaxy, past its hundreds of billions of suns, out to the neighboring galaxies, through the great clusters in the cosmic web, all the way to the edge of the observable universe, the farthest anything can be seen. And then we will stand at that edge and ask the question that has no comfortable answer: what lies beyond it? Every number in this journey is real. Every comparison has been checked. And I promise you that at least once tonight, probably more than once, you will stop and think, that cannot be right, and it will be right. And that feeling is the whole point. Before we take the first step, 3 quick things. If you are new here, subscribe, because this channel makes long, slow, deeply researched journeys through the universe. The kind you can put on at night, close your eyes, and let carry you somewhere vast. Hit the like button, because it genuinely tells the platform to show this journey to other minds who need it. And leave a comment telling me where in the world you are watching from and what time it is there, because I read every single one, and there is something quietly beautiful about knowing that this same journey outward is beginning right now from a bedroom in Nairobi, a night shift in Ohio, a rooftop in Karachi, a kitchen in Sao Paulo at 3 in the morning. Wherever you are, whatever hour it is, stay with me until the end, because the final stretch of this journey, the part beyond the last galaxies, is where the true strangeness lives, and I have saved the biggest break for last. Now settle in, get comfortable, and let us slowly ease into this. We begin with the Earth, and I want to begin here for a reason, because the Earth is the first object that is already too big for your ruler, and almost nobody notices. You live on this planet. You have seen it from photographs, a blue marble, graspable, familiar, and that familiarity is a lie your brain tells you. The Earth is 12,742 kilometers across. Numbers like that slide off the mind, so let us make it physical. If you got into a car right now and drove at a highway speed, 100 kilometers per hour, without stopping, without sleeping, without slowing, and there were a road running straight through the center of the planet, from one side to the other, the drive would take you more than 5 days. Around the equator, the full circumference, 40,000 kilometers, would take you 17 days of continuous driving, day and night, never stopping once. The deepest hole human beings have ever dug, the Kola super deep borehole in Russia, took 20 years of drilling and reached 12 kilometers down, which sounds impressive until you realize that 12 kilometers into a planet 12,700 kilometers across is the equivalent of pricking the skin of an apple with a pin and not even reaching the flesh. We live on the thinnest imaginable film on the surface of this world. All of human history, every city, every empire, every war, every love story, every grave sits in a layer thinner, proportionally, than the shine on a polished ball. The atmosphere we breathe, the entire sky, all the weather, every cloud that has ever formed, is a film about 100 kilometers thick before it fades into space, which against the size of the Earth is roughly the thickness of a coat of varnish on a classroom globe. If you could drive a car straight up, you would reach outer space in about an hour. Space is not far away. Space is an hour's drive from your front door, straight up. The Earth, this enormous world that takes 17 days to drive around, that we have not managed to drill even 1,000th of the way into, that carries 8 billion of us and every living thing we have ever found in the universe. This is our starting ruler, our first unit, the biggest thing your intuition has ever pretended to understand. Hold on to it because it is about to become very, very small. The first step outward is the moon, and this is where the breaking of the ruler begins, because I am now going to tell you something about the distance to the moon that most people refuse to believe until they see it drawn to scale. Ask anyone to picture the Earth and the moon together, and they will imagine what every textbook, every classroom poster, every diagram they have ever seen has shown them. Two globes sitting near each other, the moon a short hop away, close companions in space. Every one of those pictures is wrong, and not slightly wrong, but wildly, absurdly wrong, because no honest diagram of the Earth and moon at true scale fits comfortably on a page. The moon is, on average, 384,000 kilometers away. Here is what that means. You could take every other planet in the solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, line them all up edge to edge like beads on a string, and the entire lineup, all 7 worlds including the 2 giants, would fit in the gap between the Earth and the moon with room to spare. Every planet in the solar system fits between the Earth and the moon. Stop and sit with that for a moment, because it is the first of the sentences tonight that sounds like it cannot be right, and it is right. Jupiter alone is 11 Earths across. Saturn is 9, and all of it, everything, slots into the space between us and that small silver disk you can cover with your thumbnail. The moon is the only other world human beings have ever stood on, and getting there took the fastest vehicles our species had ever built 3 full days of travel. 12 people have made that crossing. The farthest any human being has ever been from home is the far side of the moon, and against the scale of what is coming, that crossing, the greatest voyage in the history of our species, barely counts as leaving the front porch. And here at the moon, I want to introduce the measuring tool that will carry us through the rest of this journey. The only ruler that does not break, because it is not built from the human body, but from the fabric of the universe itself. That tool is light. Light travels at 299,792 kilometers every second. It is the fastest thing that exists or can exist, the absolute speed limit of reality, woven into the laws of physics themselves. Nothing outruns it. Nothing ever will. In 1 second, a beam of light could circle the entire Earth 7.5 times. 7.5 laps of the planet, 40,000 kilometers per lap, in a single second, in the time it takes you to say the word one. Light is so fast that for all of human history it seemed instantaneous, a thing that simply arrived, and it took some of the cleverest experiments ever devised to prove it had a speed at all. So here is our new ruler. Instead of asking how many kilometers away something is, we will ask how long its light takes to reach us. And this ruler will do something wonderful and terrible as the journey continues. It will translate distance into time, and it will show you that to look out into space is always, without exception, to look back into the past. The moon, the entire lineup of planets away from us, is 1.3 light seconds distant. When you look up at the moon, you are seeing it as it was 1 1/3 seconds ago. The astronauts who stood on it spoke to Houston with a delay you could hear, every reply lagging by the round trip of radio waves crossing that gulf at the fastest speed the universe allows. 1.3 seconds. Remember that number. Feel how small it is, the length of a heartbeat and a half, because our journey has barely started, and the light times are about to grow in a way that will make the moon feel like it is touching us. One more image before we leave it behind. In 1968, the crew of Apollo 8 became the first human beings to travel to the moon, and as they came around its far side, they looked up and photographed something no one had ever seen with their own eyes. The Earth, whole, rising over the lunar horizon, a small blue and white marble hanging alone in the black. That photograph, Earthrise, is often called the most influential image ever taken, and the astronaut who shot it said something afterward that is worth carrying with us tonight. He said, "We came all this way to explore the moon, and the most important thing we discovered was the Earth." That is what scale does. Every step outward is also a mirror, and each rung of this ladder will show us our home smaller and stranger and more precious than the last. Now we turn toward the fire at the center of everything, and the ruler breaks again. The sun is 150 million kilometers away, and light, our new ruler, takes 8 minutes and 20 seconds to cross that distance. Already the translation into time is doing its quiet, unsettling work, because it means the sun you see in the sky is never the sun as it is, only the sun as it was 8 minutes ago. If the sun were somehow deleted from existence at this instant, you would not know for 8 minutes and 20 seconds. The sky would remain blue, the warmth would continue falling on your skin, the world would carry on completely normal, running on light already in flight, and then, all at once, with no warning of any kind, the sky would go black in the middle of the day, and the stars would come out, and the temperature of the world would begin to fall. 8 minutes of grace, purchased by distance. That distance, 150 million kilometers, is so foundational that astronomers gave it its own name, the astronomical unit, and it will be our stepping stone through the solar system. But before we use the sun's distance, we need to reckon with the sun's size, because this is another place where familiarity has quietly lied to you. The sun looks small, a disk in the sky the same apparent size as the moon, and your deep animal brain infiles it accordingly. As an object, a thing, a lamp. Here is the truth. The sun is 1.4 million kilometers across, 109 Earths lined up side by side. If the Earth were a grape, the sun would be a sphere 2 meters tall, a ball you could stand next to, but not reach the top of, next to your grape. Hollow the sun out like a pumpkin, and you could pour roughly 1.3 million Earths inside it. Every human being who has ever lived, every mountain range, every ocean, every civilization, multiplied 1.3 million times over, fits inside the ordinary yellow disk you squint at on a summer afternoon. And the sun is not merely large, it is dominant in a way that redraws the whole map of the solar system in your head. Add up everything that orbits it, all 8 planets, all their hundreds of moons, every asteroid in the belt, every comet, every scrap of dust and ice from here to the edge of the system, all of it together, and you have gathered 0.14% of the solar system's mass. The sun alone is the other 99.86%. The solar system is not a family of worlds with a star in the middle. The solar system is a star with some leftover crumbs still falling around it, and one of those crumbs happens to have oceans and forests and cities and you. Every second, in its core, the sun fuses about 600 million tons of hydrogen into helium, converting 4 million tons of matter directly into pure energy every second, and it has been doing this without pause for 4.5 billion years, and it has enough fuel to continue for 5 billion more. The energy released in its core is so thoroughly trapped by the dense layers above that a single photon born in the center takes, by some estimates, tens of thousands of years or more to fight its way out to the surface, bouncing from particle to particle in a drunken walk before finally escaping into space and then crossing the gulf to your eyes in a clean 8 minutes. The sunlight warming your face this morning was born in the core before the last ice age, before the pyramids, before the first cities, and spent longer escaping the sun than our species has spent having written history, and then leapt the final 150 million kilometers in the time it takes to soft-boil an egg. And yet, and here is the pivot on which this whole night turns, the sun, this monster, this 1.4 million kilometer furnace holding 99.9% of everything, 1.3 million Earths of blazing plasma, is a small star. Astronomers classify it as a yellow dwarf. Dwarf. There are stars out there, and we will meet their kind later tonight, that make our sun look the way the Earth looks next to the sun. The red supergiant Betelgeuse sitting in the shoulder of Orion where you can see it on any clear winter night is so large that if you placed it where our sun is, it would swallow Mercury, swallow Venus, swallow the Earth, swallow Mars, and its surface would boil somewhere out near the orbit of Jupiter. There are stars larger still, Hypergiants like UY Scuti and Stephenson 218, whose radii are measured in astronomical units. Stars that, if placed at our sun's position, would extend past Saturn, stars into which you could pour billions of our sun. But we are getting ahead of ourselves. For now, hold the honest picture. The disk in your sky is a 2-meter sphere to your grape, 1.33 million Earths, 99.9% of everything you have ever orbited, and on the scale of stars, it is modest, ordinary, small. That is rung 2 of the ladder. The ruler you rebuilt around the Earth just shattered against the sun, and the one you are rebuilding right now around the sun is about to shatter against the simple emptiness of the space between the worlds. Before we go any farther out, we need to stop and service the equipment, because the next stages of this journey run on words like billion and trillion. And I have learned something from years of telling these stories, which is that those words are broken for almost everyone. The human brain treats million, billion, and trillion as siblings, 3 sizes of big, like small, medium, and large coffee. And this single failure of intuition is responsible for more misunderstanding of the universe than any other. So we're going to fix it right now with time, because time is the one quantity you can genuinely feel. Here is the repair. 1 million seconds is about 11.5 days. Count one number every second, day and night without sleeping, and you reach 1 million shortly before the end of your 12th day. 11 days, a school vacation. Now 1 billion seconds. The sibling, the next coffee size up. 1 billion seconds is 31.5 years. Not 31 days, 31 years. Begin counting at the moment of your birth. 1 number per second without a single pause for your entire life. And you say the word billion in your early 30s. Gray already beginning at your temples. The gap between 1 million and 1 billion is the gap between a school vacation and everything from your birth to your first decade of adulthood. They are not siblings. They are barely the same species. In 1 trillion seconds, one more step up the same staircase is 32,000 years. Begin the count today and you finish it around the year 34,000. Deeper in the future than cave paintings are in the past. 11 days, 31 years, 32,000 years, million, billion, trillion. That is the true staircase, each step 1,000 times taller than the last, and I want you to carry it with you for the rest of tonight, because now the numbers we have already used can finally land with their real weight. When I said the sun has burned for 4.5 billion years, that is 140 billion seconds of continuous fusion, a number of seconds that itself outnumbers the stars in the galaxy by a factor of 1 billion. When I said the Milky Way holds 400 billion stars, you can now hear it properly. 12 human lifetimes of non-stop counting for the first 10 billion alone. And when later tonight I tell you the observable universe holds a septillion stars, 1 trillion, you will at least know the size of your own failure to imagine it, which is the only honest relationship anyone has ever had with that number. There is one more repair to make while we're in the workshop, and it concerns a trap even scientists fall into, the trap of the linear picture. When humans imagine a range, we imagine a line, with small things at one end and big things at the other, spaced evenly. But the universe is not built on a line. It is built on a staircase of multiplications, what mathematicians call a logarithmic scale, where each step is not an addition, but a tenfold leap. And on that staircase, the objects of the cosmos are spread out with a strange democracy. From the Planck length at the bottom to the observable universe at the top is about 61 steps of 61 orders of magnitude, and everything that exists lives somewhere on those 61 stairs. An atom sits about 25 steps above the bottom. You stand about 35 steps up. The Earth, 42. The solar system, about 48. The galaxy, 56. The whole visible universe, 61. Seen this way, seen honestly, the hierarchy loses its tyranny, because a galaxy is not unimaginably far from you on the staircase. It is 21 steps up, while an atom is 10 steps down. And the entire universe, top to bottom, is a single staircase you could sketch on one page. 61 modest steps from the smallest meaningful thing to the largest visible one. This is the great secret of thinking about scale, the trick every astronomer quietly uses. You cannot feel the numbers, no one can, but you can count the steps, and the steps are friendly. And for the rest of the night, whenever a number knocks you flat, 1,000,000,000,000 kilometers, a septillion suns, you can stand back up by asking the only question that ever has an answer your mind can hold. How many steps of 10 and the universe, which refuses to fit in your imagination, will fit just barely on your staircase? Equipment serviced. Now we climb again, and the next steps take us out of the sun's kingdom entirely. Now we step out into the solar system itself, and I want to give you the single most useful mental model of this entire journey. A scale model you can carry in your head forever, because it converts the unimaginable into the merely astonishing. Shrink the sun, all 1.4 million kilometers of it, down to the size of a basketball, about 24 centimeters across, and place that basketball in the middle of a city. Now, on this scale, where is the Earth? Most people, when asked, place it somewhere across the room, a few meters away. A marble or a golf ball. Here is the truth. On this scale, the Earth is a peppercorn, barely 2 millimeters across, orbiting the basketball at a distance of 26 meters. 26 meters, a quarter of a football field, between a basketball and a peppercorn, with absolutely nothing in between but empty space. Mercury and Venus are grains and peppercorns closer in, 10 and 19 meters out. Mars is a smaller grain at 40 meters. And then comes the great gap because Jupiter, the king of the planets, a chestnut on this scale, orbits the basketball at 135 meters, a city block and a half away. Saturn, another chestnut with its rings, sits 250 meters out. Uranus, a coffee bean, 500 meters. And Neptune, the last of the planets, another coffee bean, orbits the basketball at a distance of nearly 800 meters, most of a kilometer away. That is the solar system at true scale. A basketball, and then, scattered across an entire city district, a handful of peppercorns, chestnuts, and coffee beans, separated by hundreds of meters of nothing. If you walk that model from the basketball sun out to coffee bean Neptune, you would pass 8 tiny objects in an 800-meter walk, and you could easily miss all of them. Because the overwhelming truth of the solar system, the truth every poster and textbook diagram has hidden from you by squeezing the planets together, is that the solar system is not a collection of worlds. It is emptiness, almost perfect emptiness, decorated at enormous intervals with objects so small relative to the gaps between them that finding them at all seems like a miracle. When spacecraft navigators fly probes through the asteroid belt, the region between Mars and Jupiter that movies depict as a deadly obstacle course of tumbling rocks, they do not steer around asteroids. The asteroids are, on average, roughly 1,000,000 kilometers apart, and the real challenge is aiming carefully enough to pass close to even one on purpose. Space is not crowded. Space is the emptiest thing there is, and the solar system is our first true taste of it. Now let us restore the real distances and walk the system with our light ruler, because the times are beginning to stretch. Sunlight reaches Mercury in about 3 minutes, Venus in 6, Earth, as we know, in 8 1/3. It reaches Mars in about 12.5 minutes, which is why driving a rover on Mars is one of the strangest jobs a human being has ever had. When Mars is on the far side of its orbit, a radio command sent from Earth takes over 20 minutes to arrive, and the confirmation takes another 20 minutes to come back, which means the engineers at Mission Control are always talking to the past and hearing from the past, never the present. And if a rover is rolling toward a cliff edge, no command from Earth can arrive in time to stop it. Every instruction must be sent as a plan, hours of activity uploaded in advance, trusted to a machine 40 minutes of conversation away, alone on a world where the present moment is unreachable from Earth by any means whatsoever. Sunlight reaches Jupiter in about 43 minutes, Saturn in roughly 80, Uranus in around 2 hours, 40 minutes, and Neptune, the outermost planet, in a little over 4 hours. 4 hours at the fastest speed the universe permits, just to reach the last planet of our own home system. And human machines travel enormously slower than light. The New Horizons probe, the fastest spacecraft ever launched at the time, left Earth in 2006 moving at over 50,000 kilometers per hour, fast enough to cross the Atlantic Ocean in 6 minutes. And at that blistering speed, it took 9.5 years to reach Pluto. 9.5 years, one way, within our own solar system, in the fastest thing we could build. The people who launched it were nearly a decade older when it arrived, and its flyby of Pluto lasted a single day, a few hours of frantic photography after a 9-year silence, before it swept onward into the dark with no possibility of ever turning around. This is the scale of our own backyard, and the backyard, it turns out, extends enormously farther than the planets, because beyond Neptune, beyond Pluto, the sun's kingdom continues into realms so distant and so dark that we have never seen most of what lives there. And it is into that invisible outer country that we now go. Beyond Neptune lies the Kuiper belt, a vast ring of frozen worlds stretching from 30 to 50 astronomical units, 30 to 50 times the distance from the Earth to the Sun, a region containing hundreds of thousands of icy bodies, larger than 100 kilometers across, of which Pluto is merely the most famous citizen. Out here, the sun has shrunk to a brilliant star, still far brighter than anything else in the sky, but no longer a disk, no longer a source of any real warmth, and the temperatures hover a few tens of degrees above absolute zero. Sunlight at Pluto is more than 1,000 times dimmer than at Earth. And yet a strange and lovely fact, it is still bright enough to read by, because your eyes are extraordinary instruments, and the sun, even reduced to a point, is still ferociously luminous. High noon on Pluto looks like deep twilight on Earth, a dim silver day 4 billion kilometers from the fire. And it is out here beyond the Kuiper belt that we meet the two most distant ambassadors our species has ever sent. In 1977, humanity launched the twin Voyager spacecraft on a grand tour of the outer planets. And when their tour was complete, their momentum carried them onward, outward, on trajectories that will never return. Voyager 1 is now the most distant human-made object in existence. More than 160 astronomical units from the Sun, over 24 billion kilometers, and still moving away at 17 kilometers every second, 61,000 kilometers every hour. And it has been traveling without a single stop for very nearly 50 years. Here is what 50 years of continuous travel at 61,000 kilometers per hour buys you on the scale of the cosmos. Light covers Voyager 1's entire 50-year journey in about 22.5 hours. Our fastest, farthest, most heroic machine, launched before most people alive today were born, flying every second of every day for half a century, has achieved a distance that light crosses between one breakfast and the next. Around 120 astronomical units out, Voyager 1 crossed a boundary called the heliopause, the place where the outflowing wind of particles from the sun finally stalls against the thin gas between the stars, and in a formal sense it entered interstellar space, and the newspapers rightly celebrated. But in the truest sense, Voyager has barely left the driveway, because the sun's gravitational kingdom extends monstrously farther than its wind. Far beyond the heliopause, beginning at roughly 2,000 astronomical units, and stretching outward to perhaps 100,000 astronomical units, lies the Oort cloud, a vast spherical halo of trillions of icy bodies, the deep freeze from which the long-period comets fall, bound to the sun by gravity across distances so great that the outer edge of the cloud is nearly halfway to the next star. We have never seen the Oort cloud. No telescope can image bodies so small and so dark at such distances. We know it exists because comets keep arriving from it, falling in from every direction of the sky like snowflakes shaken loose from an invisible roof. But the cloud itself is a country we infer and have never once observed, a hidden empire of ice 1,000 times larger in radius than the entire planetary system, wrapped around everything we know. And now the numbers do their work. Voyager 1, our fastest and farthest thing, 50 years out, has covered 160 astronomical units. The inner edge of the Oort cloud begins at about 2,000. Voyager will not reach the beginning of the Oort cloud for roughly 300 more years, and it will not pass out the far side of the cloud, will not truly exit the solar system's gravitational domain for something like 30,000 years. 30,000 years. When Voyager finally leaves the sun's kingdom entirely, more time will have passed since its launch than has passed since human beings painted the caves of Lascaux, since the last ice age gripped the Earth, since our species crossed into the Americas. Entire civilizations will have risen and fallen, languages will have been born and gone extinct, and the little machine with its golden record will still be climbing out of our own front yard. That is the size of the solar system, the true size, not the poster with 9 circles, but a basketball and some peppercorns wrapped in an invisible sphere of ice so vast that our best machine needs 300 centuries to cross it. And here is the sentence I need you to hold as we stand at the edge of the Oort cloud looking outward, because it is the hinge of this entire night. Everything we have crossed so far, the moon, the sun, the planets, the belt, the cloud, all of it, the whole staggering kingdom is, on the scale of what comes next, nothing. The gap we are about to face, the gulf between our star and the very nearest of its neighbors, is of another order entirely, and crossing it, even in imagination, is where the human mind truly begins to fail. To measure what comes next, minutes and hours of light travel are no longer enough. We need the full unit, the famous one, the light year, and I want to make sure it lands properly, because it is one of the most misunderstood terms in all of science. A light year sounds like a time, but it is a distance. The distance light travels in one full year, and since light covers nearly 300,000 kilometers every second, and a year contains over 31 million seconds, one light year works out to about 9.5 trillion kilometers, 9.5 trillion. The number is beyond feeling, so anchor it this way. Voyager 1, our champion, has traveled for 50 years and covered 24 billion kilometers, which is 1/4% of a single light year. 50 years of flight, a 40th of one light year. At Voyager speed, covering one full light year would take about 17,500 years. Hold that exchange rate in your mind, 17,000 years per light year at the speed of our best machines, because now I can tell you where the nearest star is. The closest star to the sun, our very nearest stellar neighbor in the entire universe, is a small red dwarf called Proxima Centauri, part of the Alpha Centauri system, and it lies 4.25 light years away. 4.25 light years, 40 trillion kilometers. If Voyager 1 were aimed directly at Proxima Centauri, which it is not, the journey would take over 70,000 years. 70,000 years to the nearest star. Our species invented writing about 5,000 years ago. Agriculture about 12,000 years ago. 70,000 years ago, humans had not yet finished leaving Africa. A ship launched then, at Voyager speed, would just now be arriving, and every generation aboard, some 3,500 generations of travelers, would have lived and died in the crossing, on a voyage to the closest possible destination. Let us return to the basketball model and let it break your intuition properly. The sun is a basketball in the middle of your city. The Earth is a peppercorn 26 meters away. Neptune is a coffee bean 800 meters out. The whole model, the entire solar system of planets, fits comfortably inside about 2 kilometers of your city. Now, on this exact scale, where do we place the next basketball, the nearest star? Down the street, across town, in the next city. Here is the answer. On the scale where our sun is a basketball in your hands, Proxima Centauri is another ball roughly 7,000 kilometers away. If your basketball sits in New York, the nearest star is in Lisbon. If it sits in Lagos, the nearest star is in London. If it sits in Tokyo, the nearest star is in Delhi. 2 balls, on one planet, an ocean apart, and in between them, on this scale, nothing. Not a pebble, not a grain, just 7,000 kilometers of empty air standing in for 4 light years of empty vacuum. That is what interstellar space is. The distance between stars is so incomprehensibly larger than the stars themselves that if you shrank the galaxy until stars were the size of sand grains, the grains would still be kilometers apart. Space is not a sky full of stars. Space is an ocean of emptiness in which stars are almost infinitely rare motes, and the crowded star fields you see in photographs are a trick of depth. Thousands of light years of separate lonely suns flattened by your eye into a single sparkling curtain. And Proxima itself makes the loneliness stranger, because Proxima Centauri has a planet. We found it in 2016, a world called Proxima b, at least as massive as the Earth, orbiting in the zone where liquid water could exist. The nearest star to us has a potentially rocky, potentially temperate world, sitting there 4.25 light years away, the closest possible exoplanet, the first place any interstellar civilization would ever visit, and at the speed of our fastest machines, it is 70,000 years from our doorstep. It is as if we discovered an island on the horizon, close enough to see, and then learned that the ocean between us and it cannot be crossed by any boat we know how to build, or any boat our grandchildren's grandchildren will know how to build. There are serious proposals, like the breakthrough starshot concept, to change this. Plans to use powerful lasers to push tiny gram-scale probes on light sails up to 20% of the speed of light, which would cut the crossing to Proxima to a mere 20 years or so. And perhaps within some lifetimes alive today, a chip the size of a postage stamp will make that crossing and send back a photograph of another star's planet. But for anything larger than a postage stamp, for anything resembling a ship, a crew, a colony, the honest answer of physics as we know it today is that the stars are, for now and for any foreseeable future, out of reach. The light of Proxima Centauri that you could find in the southern sky tonight left that star more than 4 years ago. You are seeing years into the past with your naked eye, and this is the closest anything beyond our sun will ever be. Every other star is farther. Most are unimaginably farther. And it is to them, to the great city of stars we live inside, that we now turn. Let us widen the circle. Within about 10 light years of the sun, there are roughly a dozen stars, most of them dim red dwarfs invisible to your naked eye, scattered through a sphere of space so large that light needs a decade to cross it, and yet containing only a dozen points of matter. Within 100 light years, the count rises into the tens of thousands of stars, and 100 light years is worth pausing on, because it happens to be almost exactly the size of humanity's entire announcement to the universe. We have been broadcasting radio signals powerfully for about a century, and those signals, expanding outward at the speed of light in all directions, have now reached about 100 light years from Earth. That expanding sphere, the radio bubble, contains every transmission our species has ever made, every news broadcast, every song, every signal of every kind, and it is the totality of our presence beyond the solar system, the full extent to which the universe could, even in principle, know that we exist. 100 light years sounds respectable until you place it against the galaxy, and we will do that soon. And when we do, our century of shouting will shrink to something almost too small to draw. But first, while we stand here among the nearby stars, I want to dismantle one more comforting illusion, the constellations. When you look up at night and see Orion, or the Southern Cross, or the Big Dipper, your mind reads those stars as groups, as neighbors, as objects hanging together on a single dark ceiling. They are nothing of the kind. The stars of a constellation are almost never near each other. They are scattered across staggering depths, hundreds or thousands of light years apart along your line of sight, and they form their familiar shapes only from the accidental vantage point of Earth. In Orion, the star Bellatrix is about 250 light years away, while Alnilam, in the middle of the belt, is around 2,000. They are not companions. One is nearly 10 times deeper into space than the other, and the belt that looks like 3 stones laid neatly in a row is really 3 unrelated suns strung across more than 1,000 light years of depth, aligned by pure chance for observers standing where we stand. The night sky is not a ceiling. It is a canyon viewed from the rim with no sense of depth, and every flat pattern you have ever traced in it is a coincidence of your address. And the stars themselves, now that we are among them, are wilder than the steady white points suggest. Some are red dwarfs 1/10 the mass of our sun, so frugal with their fuel that they will burn for trillions of years, outliving the current age of the universe 100 times over. Some are blue giants that live fast and die in a few million years, ending in explosions that briefly outshine entire galaxies. There are stars smaller than cities, the neutron stars, a dead sun's worth of matter crushed into a sphere 20 kilometers across, spinning hundreds of times per second. And there are the swollen ancient giants we glimpsed earlier, the Betelgeuses and the hypergiants, stars the size of planetary orbits. Our sun sits quietly in the middle of this menagerie, unremarkable in every way, and that unremarkableness, as we will see by the end of tonight, may be the single luckiest fact about it. Now step back further. Within 1,000 light years of Earth, there are roughly 10 million stars, and 1,000 light years is about as deep as your unaided eye can reach for ordinary stars, with a few brilliant exceptions. Nearly every individual star you have ever seen with your own eyes on every night of your life lives within that 1,000 light-year bubble around us. It feels like the whole universe up there. It is a bubble, our little bubble. And here is the measurement that ends this chapter and opens the next. The galaxy we live in is 100,000 light-years across. Our entire naked eye universe. The complete sky of every camping trip and every childhood night. That 1,000 light-year bubble holding 10 million suns is 1% of the width of the Milky Way. Everything you have ever seen in the night sky with your own eyes, with the exception of a few smudges we will meet shortly, is a dot, a single sequin, on the vast spiral gown of a galaxy so much larger that its true shape has never once been seen by the species living inside it. It is time to look at the city we live in. Since we are among the stars now, let us climb a ladder within the ladder, because the stars themselves span a range of sizes that deserves its own vertigo, and our sun's position on that range is about to become very humbling. Start at the bottom with the red dwarfs, the little ones, and remember that little here still means enormous. A typical red dwarf being perhaps 15 to 50% the size of our sun, which is to say still large enough to swallow tens of thousands of Earths. These are the quiet majority of the universe, roughly 3 out of every 4 stars. Too dim for your naked eye to see a single one despite their abundance. Sipping their fuel so slowly that every red dwarf ever born is still burning, and will still be burning when the universe is 100 times its current age. The nearest star to us, Proxima Centauri, is one of these. A fire the size of 100,000 Earths that you cannot see without a telescope, which tells you something important already, that even the sky's dimness is a lie of distance. Step up to our sun, the yellow dwarf, 109 Earths across, and now keep climbing. Sirius, the brightest star in our night sky, is about 1.7 times the sun's diameter. Vega, twice. Arcturus, the orange giant lighting northern spring evenings. 25 suns across. And then the giants proper begin. Aldebaran, the red eye of Taurus, 44 suns wide. Rigel, the blue supergiant at Orion's foot. 78 suns, shining with the light of 120,000 of ours. And now the monsters. Betelgeuse, the red shoulder of Orion, which we met earlier, is so large that its diameter is measured most sensibly in astronomical units. Roughly 700 to 900 suns across, a star that placed at the center of our solar system would swallow Mercury, Venus, Earth, Mars, and the asteroid belt, its thin blazing outer layers churning somewhere near the orbit of Jupiter. Betelgeuse is also dying, expected to explode as a supernova at any time in the next 100,000 years, and when it does, for weeks it will shine in our sky brighter than the full moon, visible in daylight, the greatest celestial event in the recorded history of our species. And it may have already happened. The light of the explosion currently in flight toward us across its 640 light years. Undeliverable news. And above Betelgeuse, the true summit of the known. The largest stars we have measured are the red hypergiants, and the reigning example is a star called Stephenson, 218, deep in the constellation Scutum, roughly 20,000 light-years away, with an estimated diameter around 2,150 times that of our sun. The numbers for this star stop behaving like numbers. Placed where our sun is, its surface would extend beyond the orbit of Saturn. The Earth, the Moon, Mars, Jupiter, everything you have ever thought of as the solar system would be inside it, orbiting through its glowing outer atmosphere. Its volume could contain our sun 10 billion times over, which means, run the multiplication, it could hold on the order of 10 quadrillion Earths. A photon of light, which circles our entire planet 7 times in a second, would need almost 9 hours just to fly across Stephenson 218's diameter. An airliner attempting to circle it once would be in the air for 1,100 years. And this impossible object hangs in our own galaxy, one anonymous point among the 400 billion, invisible to your eye, unknown to almost everyone alive, discovered not by ancient stargazers, but cataloged in modern surveys. A reminder that the sky still contains things our ancestors were never told because no one knew. Now the closing move of this ladder within the ladder, the one that makes it matter. Every one of these giants, Betelgeuse, the hypergiants, all of them, is doomed precisely because of its size, burning with such fury that their lives last mere millions of years before collapse and explosion. Cosmic mayflies, while the humble red dwarfs inherit the trillions of years, and our modest sun sits in the fortunate middle, small enough to burn for 10 billion years, large and steady enough to warm a living world for the entire slow gestation of complex life. On the ladder of stars, the middle rungs are where the time is, and time is where the life is. The giants get the glory, the dwarfs get eternity. The middle, once again, gets us. The Milky Way is a barred spiral galaxy, a flattened rotating disk of stars, gas, and dust, 100,000 light-years across and roughly 1,000 light-years thick, shaped like two fried eggs pressed back to back, with a dense glowing bulge of ancient stars at the center, and great spiral arms winding outward through the disk. It contains, by the best current estimates, somewhere between 100 billion and 400 billion stars. I want to do something with that number, because numbers in the billions have stopped meaning anything to human ears, and this one deserves to be felt. Take the middle estimate, let us say 200 billion stars, and begin counting them, 1 star per second, without stopping, without sleeping, without ever pausing. 1, 2, 3, 1 star each second, day and night. To count 200 billion stars at 1 per second would take you more than 6,000 years. If you had started counting at the founding of the first cities of Mesopotamia, and your descendants had continued the count without a single second's break through the entire rise and fall of every civilization in recorded history, through Egypt and Rome and every empire since, the count would just now be finishing. That is 1 galaxy's worth of stars, counted at a rate no one could sustain, taking all of recorded human history. And around those stars, planets. We now know from the great planet hunting missions of the last decades that planets outnumber stars, that on average every star in the sky hosts at least 1 world, which means the Milky Way contains hundreds of billions of planets at minimum, and by most estimates over a trillion worlds in our galaxy alone, deserts and ice giants and lava worlds, and sprinkled among them, by conservative estimates, hundreds of millions of rocky planets orbiting in the temperate zones of their stars where liquid water could flow, hundreds of millions of potentially habitable worlds in 1 galaxy. Where is our home in all of this? The sun lies about 26,000 light years from the galactic center, roughly halfway out toward the edge of the disk, tucked into a minor spiral structure called the Orion Arm, a quiet suburban address far from the crowded, radiation-soaked downtown around the galaxy's core. And that suburban quiet, remember, is likely part of why we exist at all. And we are moving. The entire solar system, the sun and all its planets, and you, is orbiting the center of the galaxy at about 230 kilometers per second, 828,000 kilometers per hour, one of the fastest motions you will ever be part of. And at that ferocious speed, 1 complete lap around the Milky Way takes about 230 million years. That lap is called a galactic year, and it is a beautiful, dizzying unit of time. 1 galactic year ago, dinosaurs were just beginning to appear on an Earth whose continents were still fused into a single landmass. The sun has completed perhaps 20 laps of the galaxy in its entire 4.5 billion year life. Our species, in the deepest sense, has never been anywhere. In all of human existence, in the entire 300,000-year story of Homo sapiens, the solar system has moved through only about 1,000th of a single orbit of its home galaxy. We are passengers who boarded moments ago on a voyage whose single lap outlasts the age of mammals. At the center of it all, in the heart of the galactic bulge, sits the object this channel has visited before, Sagittarius, a star, a supermassive black hole of 4 million suns, the gravitational anchor of the galaxy, around which everything, every star of the 100 billions, every planet of the trillion, ultimately turns. And here is the strangest fact about our galactic home, the one that says everything about scale and our place inside it. No one has ever seen it. There is not 1 photograph of the Milky Way, not 1 real image of our galaxy from outside, and there never will be in any conceivable human future. Because to photograph the galaxy, you must leave it. And leaving it means crossing tens of thousands of light years, a journey beside which the 70,000-year crossing to Proxima is a stroll to the mailbox. Every image you have ever seen of the Milky Way from above, every beautiful spiral poster, is either an artist's rendering or a photograph of some other galaxy standing in for ours. We have mapped our galaxy the way a person locked forever inside a single room of a vast mansion might map the building from echoes and glimpses through the keyhole, brilliantly, painstakingly, and without ever once stepping outside to look at the house. You live inside an object 100,000 light-years wide, containing hundreds of billions of suns and a trillion worlds, whose true face no member of your species will ever see. And now the sentence you can feel coming, the rung breaking beneath us again. This galaxy, this incomprehensible city of stars that would take 6,000 years merely to count, is one galaxy. The universe, as far as we can see, contains something like 2 trillion of them. Before we leap into the ocean of galaxies, let us take the first step carefully to our nearest large neighbor, because it is a destination you can find with your own eyes. On a truly dark autumn night in the northern hemisphere, if you know where to look in the constellation Andromeda, you can see a faint elongated smudge, dim, easy to miss, like a tiny breath of fog on the glass of the sky. That smudge is the Andromeda Galaxy, a spiral of 1 trillion stars, larger than our own Milky Way, and it lies 2.5 million light-years away. When you find it, you are doing something extraordinary. You are seeing with nothing but your evolved primate eyes, an object whose light left it 2.5 million years ago, before our species existed. The photons landing on your retina began their journey when the most advanced humans on Earth were early members of the genus Homo, just learning to shape stones into tools. And those photons have been in flight, crossing the intergalactic dark, through the entire existence of humanity, arriving tonight in your eye at the end of a 2.5 million year journey, to be absorbed by a mind that can understand what they are. The Andromeda Galaxy is the most distant object visible to the naked human eye, and it is our closest large neighbor. Think about what that pairing means. The nearest major galaxy is so far away that its light spans the whole history of our species in transit, and everything else, the entire rest of the universe of galaxies, is farther. Most of it thousands of times farther. Our Milky Way and Andromeda are the 2 great cities of a small gravitationally bound cluster called the Local Group, a collection of about 80 galaxies, most of them small satellite dwarfs, spread across roughly 10 million light-years. The Magellanic Clouds, visible from the southern hemisphere as 2 glowing patches torn loose from the Milky Way's band, are 2 of our satellite galaxies, entire galaxies in their own right, orbiting ours the way moons orbit a planet. And the Local Group has a future, one this channel has explored before, because Andromeda and the Milky Way are not drifting apart. They are falling toward each other at about 110 kilometers per second, and in roughly 4 to 5 billion years, they will meet, pass through one another in vast slow motion, and eventually merge into a single giant galaxy, the collision in which, wonderfully, almost no stars will actually collide. Because as we now understand, stars are grains of sand kilometers apart. And even when galaxies merge, their stars slip past one another like 2 swarms of gnats passing through each other in the air. Now let us build the scale model for galaxies, the way we built the basketball model for the solar system, because your intuition needs a new anchor. Shrink the entire Milky Way, all 100,000 light-years of it, down to the size of a dinner plate 25 centimeters across. On this scale, our whole galaxy, the 6,000-year count of stars, the trillion worlds, sits on your table as a plate. Where is Andromeda? On this scale, Andromeda is another plate, slightly larger, floating about 6 meters away across the room. And this reveals one of the loveliest asymmetries in all of cosmic scale. Galaxies, unlike stars, are close together relative to their size. Remember, on the scale where stars are sand grains, the grains sit kilometers apart, separated by tens of millions of their own diameters. But galaxies are separated by mere tens of their own diameters. Andromeda is only about 25 Milky Way widths away. If stars were as close together as galaxies are, relative to their size, the night sky would be a solid wall of fire. This is why galaxy collisions are common throughout the universe, while star collisions are almost unheard of. And it means the universe of galaxies is, in its strange way, a crowded place. A cosmic archipelago where the islands are large and the channels between them, though vast beyond human meaning, are narrow in proportion. 10 million light-years of local group, 80 galaxies, two great spirals slowly falling together, and all of it, in the map of the universe, is a village. The nearest true city lies beyond, and to reach it, we must cross our largest gap yet into the realm where galaxies themselves become the grains of sand. We have been leaping from lighthouse to lighthouse, star to star, galaxy to galaxy, and it is time to ask about the dark water in between, because the gaps of the universe are not quite as empty as our models made them. And what drifts there, in the spaces between the lights, includes some of the loneliest objects in existence. And knowing about them will change the way you feel about the word empty forever. Begin with the space between the stars of our own galaxy. It is not a perfect vacuum. It is filled with the interstellar medium, a gas so tenuous that a single cubic centimeter of it, a sugar cube of interstellar space, typically contains about one atom. The same sugar cube of the air you are breathing contains about 25 quintillion molecules. The gaps between the stars are emptier than the best vacuum chambers human beings have ever constructed, and yet across the staggering volumes involved, that one atom per cubic centimeter adds up to billions of solar masses of gas and dust, enough to build generations of future stars, the thin raw fog from which every new sun condenses. And drifting through that fog unseen are worlds. Rogue planets, planets without stars, worlds that formed around suns and were then flung out by the gravitational brawls of their young systems, or that condensed alone in the dark and never had a sun at all. Sunless Earths and homeless Jupiters, sailing through interstellar space in permanent, starless night. And they are not rare. Microlensing surveys, which catch these invisible wanderers when their gravity briefly bends the light of a background star, suggest that rogue planets are astonishingly abundant, plausibly outnumbering the stars themselves, which would mean the Milky Way carries hundreds of billions of them at minimum, perhaps trillions more homeless worlds than homed ones. Somewhere out there tonight, between us and Proxima, in the gulf we called empty, there may well be worlds adrift, mountains and plains and frozen oceans under eternally starry skies, where the brightest object that ever rises is a star 4 light-years away, no brighter than the faint stars of our own sky. Worlds where noon has never once occurred. Some of them, the ice-covered ocean worlds, might even be warm inside, heated by their own radioactive cores, hiding liquid seas under kilometers of ice. And it is one of the strangest legitimate thoughts in astrobiology that the loneliest places in the galaxy, the sunless wanderers, could in principle carry life. Blind chemistries and dark oceans that will never know their sky held other things. Climb a level. The space between galaxies holds wanderers too, and theirs is a deeper exile. When galaxies collide, as they constantly do, the gravitational chaos slingshots some stars outward with such violence that they escape their galaxies entirely, and these are the intergalactic stars, the rogue suns, and surveys of the faint glow between the galaxies of great clusters suggest they are shockingly numerous, plausibly as many as 1 in 10 of all stars, torn loose and drifting in the true void, so that the space between the galaxies is faintly salted with hundreds of billions of exiled suns, many presumably carrying their planets with them into the dark. Try just once to imagine the night sky of a planet orbiting an intergalactic star, expelled long ago into the void between the Milky Way and Andromeda. There would be no stars in that sky. None. The entire sky, every night, forever would be black. Except for a scattering of faint smudges, the galaxies themselves, dim islands of light millions of light-years away, and the inhabitants of such a world, if there were any, would grow up believing the universe was almost perfectly empty. Their own sun, the only star that existed, the smudges an unsolvable riddle, and they would be able to live their entire scientific history without ever discovering what a starfield looks like. Exiles who could never learn how much they had lost. And then remember the deepest gaps of all. The cosmic voids, the booty's emptiness we met in the web, and complete the inventory honestly. Even there, in the emptiest cells of the cosmic foam, there are a few scattered galaxies and threads of thin gas, and, everywhere, without exception, the two invisible tides that fill all of space at every scale. The dark matter whose gravity sculpts the web, and the photons, the light itself, because every cubic centimeter of the universe, including the void, including the space inside your room, is crossed at this instant by the ancient microwave glow of the beginning. About 400 photons of the Big Bang's afterlight in every sugar cube of existence. Everywhere. Always. Nowhere in the universe is truly empty. Nowhere is truly dark. The gaps are not the absence of the universe. The gaps are the universe, its true substance in its overwhelming majority, faintly warm with first light, thinly salted with wanderers, and the lighthouses we have been leaping between all night are the exceptions. The glittering less than 1%. And now that you know what swims in the dark water, we can continue outward with the map finally on us. About 54 million light-years away lies the Virgo cluster, the nearest great city of galaxies. A swarm of well over 1,000 galaxies bound together by gravity, dominated by giant elliptical galaxies far larger than our own, including the mighty M87, home of the 6.5 billion solar mass black hole whose photograph, the first image of a black hole ever taken, this channel has explored before. The Virgo cluster is the downtown core of our region of the universe, and our little local group is one of countless outlying villages scattered around its gravitational influence, all of us together forming a structure called the Virgo supercluster, over 100 million light-years across, containing thousands upon thousands of galaxies. And for a long time, astronomers thought that was our full address. Then, in 2014, a team of astronomers mapping the motions of thousands of galaxies made a discovery that redrew the map. They found that our Virgo supercluster is itself only a lobe, an appendage of something far vaster, a colossal structure of galaxies, all flowing gravitationally together. And they named it Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea spans 520 million light-years and contains roughly 100,000 galaxies, 100,000 islands of hundreds of billions of stars each, all drifting in a shared gravitational basin like streams flowing toward a common sea. And the sea they flow toward is one of the eeriest objects in the cosmic map, a region called the Great Attractor, a vast concentration of mass a few hundred million light-years away toward which our galaxy and thousands of others are being pulled at hundreds of kilometers per second. For decades, the Great Attractor was doubly mysterious because it happens to lie behind the dust-choked plane of our own galaxy, in the zone of avoidance where the Milky Way blocks our view, so that we were being dragged through space towards something we could not even see. And only in recent decades have surveys peering through the dust revealed the great clusters of galaxies hiding there. You tonight, sitting still in your room, are moving toward the Great Attractor at this moment, along with your planet, your star, and your entire galaxy, part of a river of 100,000 galaxies flowing across 500 million light-years. Zoom out once more, and the true architecture of the universe finally comes into view, the largest structure that exists called the cosmic web. On the grandest scales, galaxies are not scattered randomly through space. They are arranged, woven into an immense three-dimensional lacework of filaments, vast threads of galaxies hundreds of millions of light-years long, sheets and walls of galaxies wrapping around enormous rounded hollows called voids, so that the universe, seen whole, resembles nothing so much as a sponge or a foam of soap bubbles. Or, in one of the most haunting comparisons in all of science, the network of neurons in a brain, glowing threads meeting at bright knots, surrounding dark, empty cells. The knots where filaments intersect are the great galaxy clusters. The threads between them are highways of galaxies. And the voids, the dark cells of the foam, are the emptiest places in all of existence. Regions like the Booty's Void, a cavern of space 330 million light-years across containing only a scattered handful of galaxies, where tens of thousands would be expected. A hollow so vast that it has been said that if the Milky Way had formed at its center, we would not have known other galaxies existed until deep into the 20th century, because there would have been nothing near enough to see. There are structures in this web whose scale strains even the vocabulary of astronomers. The Sloan Great Wall, a filament of galaxies 1.4 billion light-years long. The Hercules Corona Borealis Great Wall, a disputed but possibly real structure spanning up to 10 billion light-years. a significant fraction of the entire observable universe, so large that its existence troubles our theories because the universe should not have had time to organize anything so vast. And through all of it, through every filament and knot, runs the deepest open secret of the cosmic web, which is that the glowing galaxies we see are not the main event. The web is woven of dark matter, the invisible substance that outweighs ordinary matter 5-to-1, whose gravity built the filaments in the first place, and the galaxies are merely the luminous froth riding on an unseen ocean. Everything we have counted tonight, every star of every galaxy, is a minority of what actually exists. The visible trim on a structure made mostly of something we cannot see and do not yet understand. This is your full address, written out at last. You live on a planet, orbiting a star, in the Orion arm of the Milky Way galaxy, in the local group, on the outskirts of the Virgo cluster, within the Virgo supercluster, inside the Laniakea flow, woven into one filament of the cosmic web. And the web goes on, filament after filament, void after void, in every direction, to the very limit of what can be seen. It is time to go to that limit. The observable universe is the sphere of everything whose light has had time to reach us since the beginning, and its true size is one of the most misunderstood numbers in science. So let us build it carefully because there is a puzzle hiding in it. The universe is 13.8 billion years old. Light travels 1 light year per year. So you might reasonably conclude that we can see 13.8 billion light years in every direction, a sphere 27 or so billion light years across. It is a sensible answer, and it is wrong, and the reason it is wrong is one of the deepest facts about reality. The universe is expanding. Space itself has been stretching during all the billions of years that ancient light has been traveling toward us, and that stretching has carried the sources of the light farther and farther away, while their light was in flight. A galaxy whose light left it 13 billion years ago has not been sitting still, waiting for us to see it. It has been carried outward by the expansion the entire time, so that today, at this moment, that galaxy is not 13 billion light years away, but more than 30 billion. When you account fully for the expansion, the edge of the observable universe, the most distant matter whose light has reached us, currently lies about 46.5 billion light years away in every direction, which means the observable universe is a sphere 93 billion light years across, 93 billion light years containing everything we can ever see, every star, every galaxy, every photograph ever taken by every telescope, the complete visible cosmos. And I want to make sure the word observable is carrying its full weight, because it is doing something profound. The observable universe is not the universe. It is the portion of the universe visible from our particular location. A sphere centered precisely on you, defined by the reach of light in the available time, and every location in the cosmos has its own observable universe, its own sphere of visibility. A being in a galaxy at the edge of our observable universe would see their own 93 billion light-year sphere centered on themselves, containing regions we can never see, and to them, we would sit at the edge. The horizon travels with the observer, exactly as the horizon at sea travels with a ship. And just as no ship ever reaches the horizon, no observer ever sees beyond their sphere, and what lies outside it is not hidden by distance in the ordinary sense. It is hidden by time itself, by the simple fact that the universe has not existed long enough for that light to complete the crossing. And this connects to the most magical property of astronomy, one we have been using all night without naming it fully. Because light takes time to travel, every act of looking out into space is an act of looking back into time, and a telescope is, in the most literal sense, a time machine, the only one we will ever build. When you look at the moon, you see 1 1/3 seconds into the past. The sun, 8 minutes. Proxima Centauri, 4 years. Andromeda, 2.5 million years. And as our telescopes reach deeper, the look back grows monstrous. We routinely photograph galaxies whose light has traveled 5 billion years, longer than the Earth has existed. Galaxies as they were before our planet formed. The deepest images from the James Webb Space Telescope have captured galaxies whose light began its journey more than 13.4 billion years ago. Within the first few 100 million years after the Big Bang, baby galaxies from the dawn of time, photographed by a species that did not exist for 99.998% of the time their light was in transit. The universe is a layered archive, and distance is the filing system. Every shell of depth around us is an earlier chapter, and at the very edge of vision, at the bottom of the archive, we reach the oldest light that exists, and it is one of the great facts of science that we have found it and photographed it. It is called the cosmic microwave background. For its first 380,000 years, the universe was so hot and dense that it was opaque, a glowing fog of plasma through which light could not travel freely. Then, as expansion cooled the fog below a critical threshold, the universe turned transparent in a cosmic instant, and the light that was flying at that moment was released, set free, and it has been traveling ever since for 13.8 billion years, stretched by the expansion from a hot glow into a faint whisper of microwaves that now arrives at Earth from every direction of the sky, day and night, forever. That whisper is the baby picture of the universe, the wall at the edge of the visible, the oldest photograph that can ever be taken. And it is real enough that it once hissed as a fraction of the static between channels on old televisions. Part of the snow on those ancient screens was the afterglow of the Big Bang, the first light of creation, arriving 13.8 billion years late, into living rooms unnoticed between the evening programs. We live at the center of a sphere of layered time 93 billion light years across, walled by the first light that ever flew free, and everything that has ever been seen by anyone lies inside that wall. Now let us count what the sphere contains. In 1995, the director of the institute that operates the Hubble Space Telescope made a decision that many astronomers at the time considered a scandalous waste. He chose to spend 10 consecutive days of the world's most precious telescope time pointing Hubble at nothing. The target was a tiny patch of utterly empty sky near the handle of the Big Dipper, a spot chosen precisely because it contained nothing, no known stars, no known galaxies, a blank speck of blackness about the size of a grain of sand held at arm's length, 1/24 millionth of the sky. Critics said it would produce a featureless dark frame and burn 10 days of humanity's greatest instrument doing it. For 10 days, Hubble stared at the empty spot, gathering photons too faint for any previous instrument, stacking exposure on exposure. And when the image was processed, that blank speck of nothing contained over 3,000 galaxies. Not stars, galaxies, 3,000 islands of hundreds of billions of stars each, layered from relatively nearby out to the edge of visible time, crowded into a patch of sky the size of a sand grain at arm's length. A patch chosen specifically because it was empty. The image was named the Hubble Deep Field, and it is, by any honest accounting, one of the most important photographs in human history because of what it forced us to do next, which was multiply. If a sand grain of empty sky holds 3,000 galaxies, then the full sky, all 24 million sand grains of it, holds the number that redefined our universe. The current best estimates, refined by deeper surveys since, place the total number of galaxies in the observable universe at somewhere around 200 billion to 2 trillion, depending on how faint and small a collection of stars you are willing to call a galaxy. 2 trillion galaxies, each one a Milky Way or something like it, each one containing hundreds of billions of stars, each star likely dressed with planets. Multiply it through, and the number of stars in the observable universe comes out somewhere in the neighborhood of 1 followed by 23 or 24 zeros, a septillion stars, give or take an order of magnitude. And there is one comparison for that number that has become famous because it is true, and I want to give it to you properly because it deserves care. Count every grain of sand on planet Earth, every beach on every coastline of every continent, every dune of the Sahara, the Gobi, the Arabian deserts, every grain on every ocean floor. Estimates put the total number of sand grains on Earth at roughly 7.5 billion, 7.5 followed by 18 zeros. The stars outnumber them, not narrowly. For every single grain of sand on the entire planet Earth, there are on the order of 10,000 stars in the observable universe. Pick up 1 pinch of beach sand, a few hundred grains between your fingers, and you are holding the counting stones for a few million suns. The beach you walked on as a child, every grain of it, is outnumbered 10,000 to 1 by fires in the sky, and nearly every one of those fires has worlds. This is the point in the journey where I am supposed to offer you a way to grasp it, and I am going to be honest instead. There is no way to grasp it. A septillion is not a number the human brain can hold, no analogy fully lands, and the sand comparison itself, beautiful as it is, mostly just relocates the incomprehension from the sky to the beach. What you can do, what I invite you to do, is hold the two images side by side, the deep field and the sand, a blank speck of sky, chosen for its emptiness, hiding 3,000 galaxies, a pinch of sand standing in for millions of suns. And then remember the earlier rungs of our ladder. Remember that each single one of those septillion stars is a sun, a basketball to some peppercorn, 1.3 million Earths of fire, 8 minutes of light from any world that loves it, and that the gaps between them are the 7,000-kilometer gaps of our model, and that they are gathered into 2 trillion dinner plate galaxies, floating meters apart in a web of filaments and voids 93 billion light-years wide. The whole ladder, every rung, all at once. That vertigo you feel when you try, that specific sensation of the mind reaching and closing on nothing, that is the true scale of the universe. Experience the only way a human being can experience it, as a beautiful failure. And we are not done, because everything I have just described, the sphere, the septillion, the 2 trillion islands, comes with an asterisk, the largest asterisk in all of science. All of it is only the observable universe. And the universe does not end where our sight does, what lies beyond the edge of the observable universe. It is the question every child asks, the question that sounds naive and is actually one of the deepest in all of cosmology. And the honest answer comes in 2 parts. What we are confident of and what we suspect. And both parts are staggering. What we are confident of is this. The edge of the observable universe is not an edge of anything real. It is a horizon, a limit of sight, not a limit of stuff. There is no wall there, no boundary, no change of any kind at that distance. A galaxy sitting at the edge of our vision is an utterly ordinary galaxy, surrounded by more ordinary galaxies, some of which lie beyond our horizon and are therefore invisible to us forever. And the universe simply continues past our sightline, the way the ocean continues past the horizon at sea. Every measurement we can make supports this. In every direction we look, as deep as we look, the universe appears essentially the same kinds of galaxies, the same web of filaments and voids, the same physics, the same statistical texture, with no hint of thinning out, no gradient toward any edge, no sign whatsoever that we are anywhere special, or that the cosmos is wrapping up just past our view. The universe beyond the horizon almost certainly continues, and the real question is how far. And here is where the second part begins, the suspicion, and it rests on one of the most precise measurements in science, the measurement of the universe's curvature. According to Einstein, space can be curved, and a universe can, on the largest scales, have one of 3 overall shapes. It can be positively curved like the surface of a sphere, in which case it is finite, closing back on itself so that a traveler heading straight out would eventually come home from the other direction. It can be negatively curved like a saddle, opening outward forever. Or it can be perfectly flat, like an infinite sheet extending without end. Which shape our universe has is written subtly in the geometry of the ancient light of the cosmic microwave background, in the precise angular sizes of its faint ripples. And cosmologists have now measured that geometry to extraordinary precision. And the answer, as best we can determine, is that the universe is flat, or so close to perfectly flat, that no curvature can be detected at all. And a truly flat universe, taken at face value, is an infinite universe. Let me say that carefully because it is the largest idea of the entire night. If the universe is exactly flat and simply connected, then it does not merely extend some great distance beyond our horizon. It extends forever. Infinite space, infinite galaxies, infinite stars without end in any direction, of which our 93 billion light-year sphere, the entire visible cosmos, the 2 trillion galaxies, the septillion suns, would constitute precisely 0%, an infinitely small sample of an infinitely large whole. We cannot confirm this, Strictly, we can never confirm it, because no observation can reach beyond the horizon, and it remains possible that the universe is finite, but so enormous that its curvature is simply too gentle for our instruments, curled up on a scale vastly larger than what we see. The way the Earth looks flat to an ant on a football field. The most conservative reading of our measurements says the whole universe must be at least hundreds of times larger in volume than the observable part. And that is the minimum, the floor, the least it can be. The ceiling is infinity, and the leading theory of the universe's first instant makes the enormous option feel almost natural. The theory of cosmic inflation holds that in the first unimaginably tiny fraction of a second, the universe underwent a burst of expansion so violent that space itself doubled in size again and again, dozens of times over, in less time than light crosses an atom, inflating a subatomic patch into cosmic scale in an instant. Inflation explains elegantly several otherwise baffling features of our cosmos: its uniformity, its flatness, the pattern of its ripples, and it comes with a staggering implication that the region inflated to become everything we can see was a vanishing speck of a much larger inflating whole, and that the true universe beyond our horizon may be not hundreds, but trillions upon trillions of times larger than the observable sphere, or endless. Sit with the modest version, the guaranteed minimum. Everything tonight, the ladder we have climbed, rung by breaking rung, the moon, the basketball, and the peppercorn, the 70,000-year crossing, the 6,000-year count of one galaxy stars, the deep field, the sand, the 93 billion light-year sphere walled with the first light of creation, all of it at minimum, is less than 1% of 1% of what actually exists. And at maximum, it is nothing at all, a single water molecule claiming to be the ocean. The true scale of the universe in the end may simply be this: that there is no such thing as its scale, no total, no edge, no all of it, only more in every direction without end forever. There is a final twist to the story of the horizon, a melancholy one, and viewers of this channel's journey to the end of the universe will recognize its shape, because the horizon is not fixed, and the direction it is moving is not the direction you would hope. The universe's expansion is accelerating, driven by the mysterious pressure called dark energy. And that acceleration is doing something quietly dramatic to the map we have drawn tonight. It is pulling distant galaxies away from us faster and faster, and for the most distant ones, the stretching of space between us and them now outpaces the speed of their light crossing it, which means their light will never arrive, no matter how long we wait, and they have passed beyond a boundary crueler than the edge of sight, the boundary of reachability. Astronomers have done the accounting, and the result deserves to be more famous than it is. Of all the galaxies we can currently see, roughly 94% are already unreachable. Already, if we launched a signal at the speed of light tonight, aimed at one of those distant galaxies, the signal would chase it forever and never arrive, the space in between stretching faster than the message can cross it, like a runner on a track that lengthens ahead of them faster than they can sprint. We can see those galaxies because we are receiving old light they sent long ago, but we can never touch them, never signal them, never affect them in any way, and nothing from them launched today can ever reach us. They are visible ghosts present in our sky, absent from our future, and every year the accelerating expansion carries more galaxies across that line. Roughly 60,000 stars worth of matter passing beyond reach every second. And in the deep future, as this channel has explored, the process completes itself. The distant galaxies will redshift and fade one by one until, some hundreds of billions of years from now, every galaxy beyond our own gravitationally bound local group will have vanished from the sky entirely. And any astronomers alive in that era, in the merged galaxy that the Milky Way and Andromeda will by then have become, will look out into perfect blackness. We'll find no other galaxies, no cosmic web, no ancient background light, no evidence whatsoever that a larger universe ever existed, and they will conclude from flawless observations honestly interpreted that their single galaxy floats alone in an infinite void, and they will be wrong, and they will have no way, even in principle, of discovering it. which delivers quietly one of the most extraordinary facts of this entire night. We happen to be alive in the brief cosmic era when the truth is still visible. We arrived early enough to see the other galaxies before the expansion hides them, early enough to detect the afterglow of the beginning before it stretches into undetectability, early enough to read the universe's actual story in its sky. The knowledge we have assembled tonight, the ladder, the web, the horizon, the 93 billion light years, is knowledge with an expiration date, legible now, already fading, destined to become unrecoverable. The universe is a book that is slowly closing itself, and we are among the readers lucky enough to live while the pages are still open. There is one more consequence of the horizon worth holding, and then we will turn from maps to meaning. Because the observable universe is a sphere centered on the observer, and because the reachable universe is smaller still, every mind in the cosmos is, in a strict physical sense, the center of its own private universe and the prisoner of it. Our sphere of possible influence, the region of space we could ever touch, signal, or visit even with endless time and light speed travel, is a small and shrinking fraction of what we see, and what we see is at most a vanishing fraction of what exists. The universe is partitioned by light speed and expansion together into countless overlapping spheres of visibility and tinier spheres of reach. And no message, no traveler, no influence of any kind can ever pass between the distant regions. If the universe is truly infinite, then it contains infinitely many such spheres, infinitely many separate stages, forever sealed from one another, and everything that will ever happen in our sphere, all of human history past and future, everything our descendants might ever do, even granted 1 billion years and the full mastery of physics, will unfold within this one bubble, our allotted parish of the infinite, beyond whose walls we cannot ever go, and from beyond whose walls no visitor can ever come. The true scale of the universe is not only how much there is, it is how absolutely most of it is close to us, sealed behind horizons of time and expansion, an infinity we can know about but never know, shining forever just past the edge of the possible. Before we turn to what all of this means for us, there is one great question that tonight's map bears on directly. A question this channel has explored in its own full journey, and the map we have built demands we visit it here because the true scale of the universe is the silent partner in every conversation about life beyond Earth, and seeing exactly how changes both sides of that conversation at once. Here is the first side. Take the numbers we have established tonight and run them toward the question of company. 2 trillion galaxies, hundreds of billions of stars in each, planets outnumbering stars, hundreds of millions of potentially habitable worlds in our galaxy alone, and our galaxy is one of trillions, which multiplies out to something like 1 billion trillion potentially habitable planets in the observable universe. 1 billion trillion stages on which the experiment that produced you has had a chance to run. Against numbers like that, the idea that chemistry organized itself into life exactly once here and nowhere else in 1 billion trillion trials requires our world to be lucky beyond any meaningful use of the word. And this is why, for most people, truly absorbing the scale of the universe makes the existence of life elsewhere feel almost inevitable. The sheer arithmetic of worlds is the strongest argument for company that has ever been made. But tonight's map also builds a second side, the one fewer people carry home. Because the same scale that makes neighbors likely is the scale that makes them unreachable and perhaps unknowable. Remember the honest distances. 70,000 years to the nearest star at our fastest. 100,000 light years across one galaxy. 2.5 million to the next one. And remember the honest timescales, civilizations flickering for centuries or millennia against a stage that runs for billions of years. So that even if the galaxy has hosted 1,000 civilizations, they may be scattered so thinly across both space and time that no two ever overlap closely enough to touch. Ships passing not in the night, but in different centuries of the night, each arriving to find only the silence of the other's absence. The scale giveth and the scale taketh away. It fills the universe with possible life and then quarantines every instance behind gulfs that light itself needs geological ages to cross. And there is a third, stranger consequence of the map, one that tonight equips you to see clearly. Even signals which travel at the absolute speed limit are hostage to the scale. Our radio bubble, remember, is 100 light-years deep against a galaxy 100,000 light-years wide. If an identical civilization were broadcasting identically from the far side of the Milky Way, their bubble and ours, each a century deep, would be two thin films of whisper separated by a gulf 1,000 times wider than either has crossed, and neither species would hear the other for another 100,000 years, by which time both might be long gone. Two civilizations can share a single galaxy, both shouting, both listening, both concluding correctly from their own evidence that the sky is silent, and both be wrong about what the silence means. The silence, tonight's map teaches, is not evidence of absence. At these scales, silence is simply what distance sounds like. And so the scale of the universe leaves the great question exactly, maddeningly, perfectly open, and it reshapes what an answer would mean. If we are alone, then the map we built tonight is the measure of the miracle. One witness in 93 billion light years. And every number from this journey becomes a measure of how precious this world is. And if we are not alone, then the map is the measure of the separation. Company confirmed but forever distant. The universe revealed as an archipelago of isolated minds, each on its own island, each looking out at the same unbridgeable water. Either answer, run through tonight's numbers, arrives at the same shore, the overwhelming, non-negotiable value of the one inhabited world we are certain of. Whatever else the true scale of the universe implies, it implies this first, that on the only confirmed occasion when matter has awakened, it awakened here, and that everything the awakening has ever produced, every mind, every language, every act of love, and every act of understanding, including this journey we are sharing right now across the internet of one small planet, is contained on a single peppercorn, 26 meters from a basketball, in a suburb of one spiral among 2 trillion. The stakes of that sentence do not depend on how the great question resolves. They are the floor beneath both answers, and they are the reason that learning the true scale of the universe is not an escape from caring about the Earth, but the strongest argument for it that has ever been assembled. Now I want to do something unexpected. We have climbed the ladder outward as far as sight and reason can go, and before we talk about what any of it means, we are going to turn around and climb the other way, downward, inward, into the small. Because the true scale of the universe runs in both directions, and the abyss below is every bit as deep as the abyss above. And it ends with a revelation about you sitting there that rivals anything we have found in the sky. Start with your hand again, the 10-centimeter ruler. Zoom in. A single one of your cells is about 10 to 100 times smaller than a millimeter, invisible to your eye, and your body contains some 37 trillion of them. Each one a bustling city of molecular machinery, reading genetic code, building proteins, generating power, a metropolis of activity in every invisible speck of you. Zoom in further, past the cell, past its intricate organs, down to the molecules, and then to the atoms themselves, and here the numbers detonate again. A single atom is about 1/10 of a nanometer across, so small that the comparison has become classic because nothing else lands. There are more atoms in a single glass of water than there are glasses of water in all the oceans of the Earth. More atoms in one glass than glasses in every sea. Your body contains roughly 7 octillion atoms, a 7 followed by 27 zeros, which means delightfully that the count of atoms in your single body is within a few orders of magnitude of the count of stars in the entire observable universe. You are numerically a universe of atoms contemplating a universe of stars, and the two numbers are almost neighbors. And the atom is where the great secret of the small is hiding, the one that mirrors everything we learned in the sky. Picture an atom as school diagrams drew it, a cluster of particles at the center with electrons circling close around. Like the solar system posters, the diagram is a lie of compression. An atom is a tiny dense nucleus wrapped in a vast cloud of electron probability, and the proportions are ferocious. If you scaled a hydrogen atom up until its nucleus, its single proton were the size of a marble sitting at the center of a great stadium, the electron's domain would be the entire stadium. All the stands, all the airspace out past the last row of seats, and between the marble and the stands, there would be nothing. The atom, the very substance of solidity, is more than 99.999999999% empty space, which means you are too. The floor you stand on, the chair holding you, the walls of your room, your own bones, all of it is overwhelmingly, almost perfectly nothing. A haze of vanishingly tiny nuclei suspended in emptiness, held apart and given the illusion of solidity by electric fields. If you could somehow squeeze all the empty space out of the atoms of every human being on Earth, all 8 billion people, the remaining actual matter would fit in a volume smaller than a sugar cube. A single sugar cube with the mass of humanity, which is, and this is the loveliest closing of a circle in all of physics, precisely what a neutron star is. Matter with the emptiness crushed out of it, which is why a teaspoon of neutron star weighs billions of tons. The emptiness of the atom and the density of the dead star are the same fact, seen from opposite ends. So hold the symmetry now, because it is exact. We climbed outward and found that the solar system is emptiness dotted with rare worlds, that interstellar space is emptiness dotted with rare stars, that the cosmic web is emptiness dotted with rare galaxies. And we climb inward and find that matter itself, the very stuff of the dots, is emptiness dotted with rare specks of substance. Emptiness above, emptiness below, emptiness within. The universe is not a thing that contains some empty space. The universe is emptiness, structured, patterned, electrified, and shot through at every scale with vanishingly rare concentrations of something, and one of those concentrations, improbably on one wet rock, has arranged itself into a pattern that can notice all this and feel dizzy about it. And below the atom, the ladder keeps descending to the protons and neutrons, and inside them to the quarks, and somewhere far beneath everything, at 10 to the minus 35 meters, physics reaches the Planck length, the scale where our concepts of space and distance themselves are believed to dissolve. The floor of reality as we understand it, so remote from the atom that the atom towers over the Planck length by a greater factor than the observable universe towers over you. Read that again. You are closer in scale to the entire observable universe than a single atom is to the smallest meaningful length. The abyss going down is deeper than the abyss going up. And you live between them, on the middle floors of an endless building, with infinity above the roof and infinity below the basement. And it is precisely there, in the middle, that things get interesting. Here is a question you have probably never asked, because the answer seems obvious. How fast are you moving right now? You are sitting still, lying still, holding still, and the obvious answer is 0, and the obvious answer is spectacularly wrong. And unpacking exactly how wrong is one of the most vertiginous exercises in all of science. Because motion, like size, is layered, and every rung of tonight's ladder comes with its own hidden speed, and you are riding all of them at once. Begin with the Earth's spin. The planet rotates once per day, and at the equator that rotation carries the ground, and everything on it, eastward at about 1,670 kilometers per hour, faster than the speed of sound. If you live at mid-latitudes, your share is somewhat less, but you are, at this moment, being swept sideways at roughly the speed of a jet airliner. And you feel nothing because everything around you, the air, the buildings, the oceans, is moving with you. And motion shared is motion invisible. Next rung, the spinning Earth is also orbiting the sun, and the orbital speed of our planet is 107,000 kilometers per hour, 30 kilometers every second. In the time it took you to hear that sentence, you traveled about 150 kilometers through space. Since you started watching this video, you have traveled farther through the solar system than most people travel in a year of driving, and you have felt none of it sitting still in your room, which is a cannonball. Next rung, the sun carrying the Earth and you is orbiting the center of the Milky Way at about 828,000 kilometers per hour, 230 kilometers per second, sweeping through the galactic suburbs, threading between the neighborhood stars, completing one lap every 230 million years. And the rungs continue above even that, because the Milky Way itself is falling toward Andromeda at about 110 kilometers per second, and the whole local group is streaming through the Laniakea flow toward the Great Attractor. And when astronomers measure our total motion against the only universal reference frame that exists, the cosmic microwave background itself, the ancient light of the beginning. They find that our galaxy, with everything in it, with you in it, is moving through the universe at about 600 kilometers per second, over 2 million kilometers per hour, toward a point in the southern sky, 2 million kilometers per hour. That is your true current speed, right now against the oldest light in existence, while you sit perfectly still. You have never been still, not for one instant of your life. Stillness does not exist anywhere in the universe, has never existed, cannot exist. Every atom you own has been in continuous, layered, compound motion since the moment it was forged, spinning around a planetary axis that orbits a star that orbits a galaxy that falls through a supercluster that rides the expansion of space itself. And the calm you feel, the profound solidity of a quiet room at night, is the deepest illusion the universe tells. Motion so vast, so smooth, and so universally shared that it wears the costume of perfect rest. And there is a beautiful consequence hiding in all this layered motion, one that changes what a year even is. Because the sun is moving through the galaxy while the Earth circles it, our planet does not actually travel in a closed ellipse. It traces a vast spiral, a corkscrew, helixing through interstellar space behind its moving star, never once returning to any point it has occupied before. You have never been in the same place twice. The house you grew up in, as a location in the galaxy, is trillions of kilometers behind you, receding forever, and every birthday you have celebrated happened in a different region of interstellar space, hundreds of billions of kilometers from the last. There is no going back, not to anywhere, only to whens remembered, in places whose coordinates the galaxy has long since left behind. The universe is not a hall of fixed places. It is a torrent, all currents and no banks, and everything in it, from the photons to the superclusters, is in flight. And the true scale of the universe is therefore not only a scale of size, but a scale of ceaseless, layered, magnificent speed, in which the fastest thing you will ever do is what you are doing right now, resting. There is one more dimension of scale we owe this journey, and it is the one hiding inside all the others, time itself, because the universe is vast not only in space but in duration, and the two vastnesses are woven together. And a few minutes spent honestly feeling the depth of time will complete the picture in a way nothing else can. The universe is 13.8 billion years old, and we repaired the word billion earlier tonight. So you know what that claim is really making, a claim of 435 million billion seconds. But even the repaired number needs a body to live in. So let us give it one, using the most famous device ever invented for the purpose, the cosmic calendar, in which the entire history of the universe is compressed into a single year. The Big Bang is midnight, January 1st. Every month of this calendar is a little over 1 billion years. Every day is nearly 38 million years. Every single second of this compressed year is 437 real years. Now watch the year unfold. Through January, the first stars ignite and the first galaxies begin to assemble. Our Milky Way takes shape somewhere in the late winter and spring, and then the calendar simply turns. Month after month, stars living and dying, generations of them cooking the elements, seeding the gas for the entire spring and the entire summer. An expanse of time our minds slide over in a sentence which represents 9 billion years. More time than the current age of the Earth doubled, before our own story even begins. The sun and its planets do not form until September 1st. The Earth cools, the oceans condense, and the first simple life appears in late September, remarkably early in our planet's story, as we have discussed on this channel before. But then, and here is the humbling stretch, life stays microscopic for 2.5 months of the calendar, October, November, into December. Billions of real years of nothing but single cells, the longest chapter of our history and the least told. Complex animals arrive only in mid-December. Fish, then forests, then the first footsteps on land in the calendar's final 2 weeks. Dinosaurs rule from roughly Christmas morning until the evening of December 30th, when the asteroid ends them. In the entire age of mammals, everything from that catastrophe to this moment fits into the calendar's final day, and us. All of recorded human history, every civilization, every pharaoh and philosopher, every cathedral, every war, every book ever written, every name ever remembered, occupies the last 13 seconds of December 31st. The pyramids went up 10 seconds ago. Rome fell 3.5 seconds ago. The telescope was invented 1 second ago. Your entire life, however long you live, is a fraction of the final compressed second before midnight. And here is the point of the whole device. The reason it earns its place in this journey. Every one of the light travel times we have used tonight is also a depth in this calendar. When you look at the Andromeda galaxy, it's 2.5 million-year-old light left in the final hour of the cosmic year. The deep field galaxies shine at us from January and February. The microwave background is the flash of the first instant after midnight, still crossing the room. To look out in space is to look down through the calendar, through the year, toward the first stroke of the clock. And astronomy is, in the most literal sense, the study of the past tense of the universe, the one science whose entire subject matter is history, delivered by light. And the calendar has a final gift, pointed the other way. On this same scale, compressing all past time into a year, how much is left? The sun has 5 billion years of stable burning remaining, another 4 months of calendar. The stars as a whole, as our journey to the end of the universe explored, have 100 trillion years ahead, which on this calendar is not another year or another century of calendar years, but over 7,000 more years of cosmic calendars stacked end to end. And the universe's full story stretches beyond even that into numbers that bury the metaphor. We are not living at the end of time or the middle of time. On the honest ledger, we are living in the first instance of the universe's story, the opening seconds of its second year, early beyond all intuition, and every question tonight about where everything is and how big it all stretches shares its answer with the question of when we are, which is almost unbearably at the very beginning. Now that both directions of the ladder are open to us, the outward and the inward, I want to give you the whole thing as a single continuous motion, one unbroken zoom, because scale is not really a set of separate facts. It is one seamless fabric, and there is a way of traveling it, made famous by a short film from 1977 called Powers of 10, that remains the single most effective meditation on the universe ever devised. And we are going to do our own version of it right now, with your eyes closed if you like. Begin 1 meter from your own hand, an ordinary human view, and now begin to rise, multiplying your distance by 10 with every step. 10 meters, and you see your room, your building, the shape of your immediate life. 100 meters, your street and its neighbors, the scale of a village, the largest space most humans before the modern era ever deeply knew. 1,000 meters, 1 kilometer, your whole district, and already individual people have vanished. 10 kilometers, the whole city, all its millions, a texture. 100 kilometers, and you break through the varnish of the atmosphere into space. The city a glowing patch, the sky now beneath you. 1,000 kilometers, the curve of the earth fills your view. 10,000 kilometers, the whole planet floats before you. The blue marble, the overview effect in a single step. 100,000 kilometers, the earth shrinks to a ball at arm's length. 1,000,000 kilometers, and the moon's orbit fits in your view. The whole domain of human travel, a small ring around a small world. 10 million, 100 million kilometers. The orbits of our neighbor planets open around you like ripples. 1 billion kilometers, the inner solar system entire. 10 billion in Neptune's orbit, the whole planetary system, the basketball in every being, is a disk you could cup in your hands. 100 billion, 1 trillion kilometers. The system shrinks to a bright dot wrapped in the darkness of the inner Oort cloud, and you hang in true interstellar blackness now. The sun, just the brightest star among stars. 10 trillion kilometers, 1 light year, the Oort cloud's far shores. And here the zoom grows lonely, because 100 trillion kilometers, 10 light years, brings only the first dozen neighboring stars into your view. And the step after that, 100 light years, swallows our entire radio bubble, every signal humanity has ever sent in a single frame among thousands of stars. 1,000 light years, our whole naked eye sky, the bubble of every human night, one sequin. 10,000 light years, the spiral arm. 100,000 light years, and there it is, at last, the thing no human eye has seen, the whole Milky Way, the city of 400 billion. a slow silver whirlpool filling your view. 1,000,000 light years, and the galaxy shrinks to a glowing coin. Its satellite dwarfs around it like moths. 10 million light years, the local group, our village of galaxies, plates on a dark table. 100 million light years, the Virgo neighborhood, hundreds of galaxies, the first threads of the web discernible. 1,000,000,000 light years, and the structure of everything is before you. The cosmic web whole, filaments and voids, the foam of creation. Galaxies now mere points of texture, and superclusters like Laniakea just knots in the lace. 10 billion light years, and you approach the wall, the edge of light, the sphere of all sight, the 93 billion light-year bubble hanging complete in your imagination, containing every photograph ever taken, every star ever wished upon, every question ever asked. 46 steps of 10, from your hand to everything. And now fall. Reverse the zoom and drop, 10 times closer with every heartbeat, through the web, into the filament, into the local group, into the spiral, down the arm, through the bubble of familiar stars, into the system, past the beans and the peppercorn, down through the varnished sky to your city, your street, your room, your hand 1 meter, and do not stop. 10 centimeters, the skin's landscape. A centimeter, a millimeter, the fine grain of your fingerprint like plowed fields. 1/10 of a millimeter, and a single cell fills your view, alive, working. Down through the cell's machinery, 10,000ths, millions of a meter, into the writhing molecular crowds, until at a 10 billionth of a meter, a single atom hangs before you. A stadium of emptiness around an invisible marble, and still you fall, 5 more steps of 10 to reach the nucleus, and then further, past the protons, toward the quarks, toward the Planck depths, 20 more steps below, where the zoom itself dissolves because space stops meaning. 61 steps of 10, top to bottom, and you have now walked every single one of them in a few minutes of imagination, hand to universe to hand to atom, the complete staircase of existence. And here is the closing thought of the exercise, the one the film's makers understood half a century ago. At every one of those 61 landings, at every scale without exception, there was structure, pattern, something happening. Worlds within worlds within worlds, and the only landing on the entire staircase where any of it is known to be noticed, the only floor with a witness, is the one you started from. Yours. It is worth stopping to ask a question that this entire journey has quietly assumed, and the answer is one of the great adventure stories of our species. How do we know any of these distances? No tape measure reaches the stars. No spacecraft has visited another sun. Every number tonight, the 4 light years, the 2.5 million, the 93 billion, was measured from the surface of, or near orbit around, a single small planet by creatures who cannot leave it. And the way they did it is called the cosmic distance ladder. And it is exactly what it sounds like. A ladder, each rung calibrated by the rung below, reaching from the ground beneath your feet to the edge of the visible universe. The first rung is geometry, the oldest tool we have. Hold a finger at arm's length and close one eye, then the other, and watch the finger jump against the background. That jump is parallax, and its size depends on the distance to the finger. Astronomers do the same with stars, using the Earth's orbit as the space between the eyes. Photograph a nearby star in January, photograph it again in July when the Earth is 300 million kilometers away, on the far side of the sun, and the star shifts minutely against the distant background, and from that shift, pure trigonometry delivers the distance. The shifts are fantastically small, the largest of them under 1 second of arc, the apparent width of a coin seen from kilometers away, which is why the ancients, who understood the method perfectly, could not detect it and concluded the stars must be a fixed sphere. It took until 1838 for instruments to sharpen enough for the astronomer Friedrich Bessel to measure the first stellar parallax and hand humanity its first true distance to a star. And in our own era, space observatories like Gaia have measured the parallaxes of nearly 2 billion stars, building a 3-dimensional map of our galactic neighborhood out to tens of thousands of light years, all of it resting on the simple jump of a finger between 2 eyes. But parallax fades with distance, and beyond its reach we needed a second rung, and it was built by one of the most quietly heroic figures in the history of science, a woman named Henrietta Swan Leavitt, working in the early 1900s at the Harvard Observatory as a computer, the era's term for the women who analyzed the photographic plates, paid 30 cents an hour and barred from using the great telescopes themselves. Studying thousands of variable stars, stars that brighten and dim in regular cycles, Leavitt discovered something extraordinary in a class called Cepheids, that the rhythm of their pulsing revealed their true brightness. The slower the cycle, the more luminous the star. And true brightness is the key to everything. Because if you know how bright a light really is, and you see how bright it appears, the dimming tells you the distance, just as you can judge the distance to a street lamp at night, because you know what a street lamp should look like up close. Leavitt had discovered a standard candle, a lighthouse whose wattage is written in its flicker, and Cepheids are luminous enough to be seen in other galaxies. Within 15 years, Edwin Hubble had found Cepheids in the Andromeda Nebula, applied Leavitt's law, and proven that Andromeda lay far beyond the Milky Way, that it was a separate galaxy, and that the universe was made of galaxies, unimaginably vaster than anyone had established before. The single greatest expansion of the known universe in human history rested directly on the pattern found by a woman who was never allowed to point the telescope. And beyond the Cepheids, a third rung, the supernovae, specifically the type called 1A, exploding white dwarf stars that detonate with such uniformity that they shine as standard candles visible more than halfway across the observable universe. And it was these stellar bombs, calibrated against Cepheids, calibrated against parallax, calibrated against the width of the Earth's orbit, that led astronomers in 1998 measure the expansion history of the cosmos and discover that the expansion is accelerating. The discovery of dark energy, a Nobel Prize in the fate of the universe, resting on a ladder whose bottom rung is a finger held at arm's length. That is how a species pinned to one rock measured a sphere 93 billion light years wide. No magic, no leap, just rung after rung, each one trusted only as far as the rung below could hold it. Geometry to pulsing stars to exploding stars to the edge of everything. 100 years of patient calibration. And I want you to notice what kind of achievement that is. Every number that broke your intuition tonight was assembled by intuitions exactly as breakable as yours, by minds the same size as yours, who simply refused to stop climbing. The universe did not hand us its scale. We took it, rung by rung, and the ladder is still being extended, and its lower rungs are still being checked and rechecked to this day, because in science, even the edge of the universe hangs from the humblest measurements honestly made. There is a question that rises naturally out of all this immensity, and it deserves a serious answer rather than a shrug. Why is the universe so big? Why this absurd overabundance, trillions of galaxies, septillions of stars, when one warm world under one steady sun would seem to be all that a story like ours requires? Framed that way, the size of the universe can feel like mockery, an extravagance that reduces us to a rounding error, and many people, on first truly confronting the scale, feel something like insult, as though the universe's vastness were a comment on our unimportance. But there is a stunning reply to this feeling, and it comes not from philosophy, but from physics, and it is this: the universe has to be this big for you to exist at all. The size is not extravagance. The size is a requirement, and the argument runs through the atoms of your own body. You are made of complex elements, carbon in every cell, oxygen in the water of your blood, calcium in your bones, iron in the hemoglobin carrying breath through you at this moment. And as we have said before on this channel, those elements are not primordial. The Big Bang produced hydrogen, helium, and almost nothing else. Every heavier atom, everything interesting, everything life is built from, was forged afterwards in the nuclear furnaces of stars, fused step by step in stellar cores over billions of years, and then scattered into space by stellar deaths so the next generation of stars and planets could inherit it. Your body is, atom by atom, the output of that process, requiring generations of stars to live and die before a world like Earth, rich in heavy elements, could form at all. And that process takes time. Billions of years of stellar cooking before the ingredients of biology existed in useful amounts, then more billions for a planet to form, settle, and grow its chemistry toward life. Then more billions still for evolution to work its slow way from the first cells to a creature that can look up. The minimum age for a universe containing beings like you is measured in billions of years. There is no shortcut, no faster route from hydrogen to astronomers, and now the lock clicks shut. The universe is expanding, and it has been expanding for its entire history, which means age and size are welded together. A universe billions of years old is necessarily billions of light years across, because it has been growing every moment of that time. You cannot have a small, cozy, human-scaled universe that has also existed long enough to build humans, any more than you can have a 100-year-old oak tree the size of a seedling. The vast dark gulfs that dwarf us, the billions of light years of apparent emptiness, are the very signature of the time it took to make us. The universe is enormous because it is old, and it is old because that is how long we take to grow. When you feel small under the night sky, you are, in the most literal sense, feeling the size of your own gestation. The emptiness is not indifference. The emptiness is the stretch marks of a cosmos that spent 13.8 billion years pregnant with the possibility of minds. In every light year of dark between the galaxies is time that was spent, in part, assembling the iron now moving through your veins. There is a related thought, gentler and stranger, worth placing beside this one. We often speak as though the universe's scale diminishes us, as though the comparison ran only one way. But consider what the comparison actually requires. The universe, for all its septillion stars, does not know it is large. Size without a witness is not grandeur. It is just quantity, unexperienced, unmeasured, unfelt. A galaxy cannot marvel. A supercluster has never once felt awe. In the entire inventory of the cosmos that we have toured tonight, the only objects we know of that can be overwhelmed by the scale of the universe are the very small, soft creatures doing the touring. The vastness became vast in any meaningful sense only when something arose that could measure it and tremble. And as far as we currently know, that trembling happens nowhere else but behind eyes like yours. The universe is very large, but large is a word, and words, so far as we have ever discovered, are made only here. Hold both of these truths together, the physics and the poetry, and the scale stops reading as mockery. The universe is not too big for us. It is exactly the size a universe must be to contain someone capable of asking why it is so big. And the question itself, asked tonight by you in the dark on a peppercorn, is the cosmos completing a circuit 13.8 billion years in the wiring? Everything in this journey has been delivered in words and numbers. And before we close, I want to hand you something better. A way to verify the scale of the universe yourself tonight or the next clear night, with no equipment at all, because the depth we have been describing is not hidden away in observatories. It is standing in your sky right now, layered and labeled. If you know how to read it, and reading it just once with your own eyes will do more than any hour of listening. Step outside on a clear night and look up, and understand that you are not looking at a surface. You are looking down a corridor of time, and every object in your sky sits at a different depth in it. And here's the tour from near to far, entirely in things your naked eye can find. Start with the moon if it is up. 1 1/3 light seconds. You see it as it was during your last breath. It is the only object in your sky whose light is younger than your current thought. Find a bright planet if one is visible, Venus blazing near the horizon after sunset, or Jupiter riding high, and know that you are seeing minutes into the past, 5, 10, 40 minutes, depending on the geometry. Sunlight that flew from the sun, bounced off another world, and crossed to your eye while you were making dinner. Now the stars, and this is where the corridor opens. Find Sirius, the brightest star in the entire night sky, unmistakable, flashing white and blue low in the winter sky. Its light is 8.6 years old. You are seeing Sirius as it was roughly 2 American presidential terms ago, and everything that has happened in your life since then, every move, every loss, every beginning, happened while that light was in flight to meet your eye at this exact moment. Find Vega, brilliant overhead on summer evenings in the north, 25 years deep. If you are around 25 years old, Vega's light left the star approximately when you were born and has been falling toward this night your entire life. Your personal photon, arriving on schedule. Older viewers can find their birth light farther out, Aldebaran at 65 years. And if you were born around 430 years ago, you would claim Polaris, the North Star, whose steady light is 4 1/3 centuries deep. Light that left during the age of Shakespeare and Galileo, navigating ships and guiding the enslaved northward, and holding its post through every one of the 14 or so generations that have lived and died during its crossing. And then find Deneb, the tail of the swan, the top of the Northern Cross, one of the brightest stars of the summer sky, and take a breath because Deneb is roughly 2,500 light years away, one of the most distant individual stars your naked eye can see well, and its light left around the time of the classical Greeks. When you look at Deneb, you are seeing the sky's deep past with no instrument, but your own evolved eye, photons that departed before Rome, before most of the world's living religions, arriving tonight into you. And finally, if your sky is dark enough and the season is right, perform the deepest act of unaided seeing a human being can perform, and find the Andromeda galaxy, the faint elongated smudge we visited earlier, and hold in your mind while you look at it the full truth of what is happening. 2.5 million-year-old light, 1 trillion stars delivering their combined glow across a gulf 25 galaxy widths wide, into a lens of jelly the width of your fingertip, focused onto cells that translate it into the experience you are having. An experience which is, in the strictest physical sense, a direct touch. Because those very photons, the actual particles that left Andromeda while your ancestors were learning the stone tools, are ending their existence inside your body. Astronomy is the only field where the object of study physically enters the student. And notice while you stand there, what your sky tour has demonstrated. Every depth was different. The corridor was real. The moon at seconds, planets at minutes, Sirius at years, Polaris at centuries, Deneb at millennia, Andromeda at the depth of our species, all of them visible simultaneously, layered in one black dome, a complete cross-section of cosmic scale, from your breath to the age of humanity, free of charge, most clear nights above your house. People travel across the world to see canyons a kilometer deep. The canyon above your roof is 2.5 million light years deep, and its far wall is a galaxy, and almost nobody ever looks. Be one of the people who looks. Take this journey's numbers outside, attach them to the actual lights, and the true scale of the universe will stop being something you heard about in a video and become something that happened to you personally one night under the sky. One more gift from the corridor before you go back inside. While you stand under that layered sky, hold up your thumb at arm's length and know that behind it, behind that one thumb width of darkness, wherever you point it, there are, by the deep field arithmetic, tens of millions of galaxies. Every thumb width, every direction, all night, every night, whether anyone points or not. And that from now on, for the rest of your life, you will know that, and the sky will never again be a ceiling, and a thumb will never again be only a thumb. In February of 1990, the Voyager 1 spacecraft, its planetary mission complete, was 6 billion kilometers from home, sailing outward past the orbit of Neptune toward the interstellar dark when it received an unusual command from Earth. Turn around. Not the ship, just the camera. The astronomer Carl Sagan had spent years persuading the mission's leadership to do something with no scientific value whatsoever, to spend precious resources pointing Voyager's camera back the way it had come, at the inner solar system, at us, for no reason except that the picture would matter. There were objections. The camera would be aimed dangerously near the sun. The Earth at that distance would be almost nothing. That, Sagan argued, was exactly the point. And so on Valentine's Day of 1990, Voyager took the photograph, and in the frame, caught by chance in a stray band of scattered sunlight like a fleck of dust in a sunbeam through a window, was the Earth, 6 billion kilometers away, smaller than a single pixel. A pale blue dot. You have to be told which speck it is. Nothing about the image distinguishes our world from a flaw in the film, a mote on the lens. And yet, as Sagan wrote in the passage that has become one of the most beloved meditations in the history of science, that dot is everything. Every human being who has ever lived there. Every hunter and forager, every hero and coward, every creator and destroyer of civilizations, every king and peasant, every young couple in love, every mother and father, every hopeful child, every inventor and explorer, every teacher, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species, on a mote of dust suspended in a sunbeam. All our wars, he observed, have been fought over fractions of that pixel, rivers of blood spilled by generals and emperors so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. The photograph adds nothing to our knowledge of the Earth. It rearranges, permanently, our knowledge of ourselves. And it is the single best answer our species has ever produced to the question of what the scale of the universe is for. Perspective, it turns out, is not an abstraction. It is something that happens to people, physically, and we know this because of the small number of humans who have experienced the scale of things directly. Astronauts looking back at the whole Earth from orbit or from the moon report an experience so consistent that psychologists have given it a name, the overview effect, a sudden, overwhelming, often tearful shift in awareness, in which the borders between nations become invisible. The atmosphere reveals itself as a film of breath thinner than the skin on an apple. The planet stops being a location and becomes, unmistakably, a single small shared vessel, and the conflicts of its passengers seem, for a moment, incomprehensible. Astronaut after astronaut from every nation that has flown them has come home describing the same transformation, some devoting the rest of their lives to causes of peace or conservation because of a few minutes spent at the right distance. Edgar Mitchell, returning from the moon, described looking at the Earth from deep space and feeling an instant global consciousness, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. From out there, he said, international politics looks so petty. You want to grab a politician by the scruff of the neck and drag him 250,000 miles out and say, look at that. That is the testimony of the only people who have ever climbed even the first rung of tonight's ladder in person, 1.3 light seconds, the distance we crossed in the opening minutes of this journey and then dwarfed 1 billion times over. One rung was enough to change every single one of them. And here is what that means for you tonight. You cannot ride the rocket, but you have just made in mind a voyage no astronaut has approached. Out past the basketball-and-peppercorn, past the 70,000-year gulf, through the 6,000-year count of stars, beyond the deep field in the sand, to the wall of first light in the edge of the reachable and back. The overview effect is, at its heart, not about altitude. It is about honestly absorbing the true size of things, and that is available from a bedroom at night, with the lights off, which is perhaps why you're here. The universe does not require you to leave the Earth to be changed by it. It only requires you to look up and refuse to look away until the ruler breaks. So we arrive at the question underneath all the numbers, the one this entire night has been quietly building toward. Confronted with the true scale of the universe, what are we supposed to feel? The reflexive answer, the one our culture reaches for automatically, is insignificance. We are nothing, the sigh goes, a speck on a speck orbiting a spark among a septillion sparks, and nothing we do can matter against such immensity. And I want to take that feeling seriously rather than dismiss it, because it is honest, and there is real medicine in it. There is a genuine relief in smallness. The argument you lost, the deadline you missed, the embarrassment replaying in your head at 2 a.m, hold any of them up against the Hubble deep field and feel them lose mass. Scale is a solvent for the false emergencies of a human day, and using the universe this way, as a quiet room to set your worries down in, is one of the oldest and healthiest things people do with the night sky, and it is a large part of why channels like this one exist and why you may be listening with your eyes closed right now. Smallness, honestly felt, is not despair. It is unburdening. But insignificance is the wrong conclusion, and I want to close tonight by arguing against it, carefully, using only what we have actually seen on this journey, because the case for our significance is not sentimental, it is observational. Consider what tonight actually revealed. We toured a universe of septillion stars, and everywhere we looked we found magnificent, blazing, utterly mindless matter. Suns burning by the trillion with no one to warm. Galaxies colliding in slow, gorgeous silence with no one to gasp. Nowhere in the entire inventory, not in the Kuiper belt, not around Proxima, not in the Virgo cluster, not in the deep field. Have we yet found one other place where the matter has organized itself into the trick you are performing at this instant, the trick of knowing? As far as our evidence currently extends, and it now extends across 93 billion light years, the ability to understand this universe exists in exactly one location, a film of chemistry on a peppercorn, and you are it. Rarity is the very thing that makes small objects precious, a principle every human being already accepts. A diamond is a speck against a mountain, and worth more than the mountain because of what is arranged inside it. If value tracked volume, we would treasure gravel and discard children. Nothing anywhere is valuable by being big. Things are valuable by being rare and organized and irreplaceable. And by that standard, the standard we actually live by, the most valuable structures in the known universe are not the hypergiant stars or the great walls of galaxies, but the 3-pound universes of ordered matter behind human eyes, each one containing more synaptic connections than there are stars in the Milky Way. Each one capable of doing what no galaxy can do, which is to care. And notice finally what the scale of the universe turned out to be made of on every single rung. Emptiness. That was the discovery we made over and over tonight at every level in both directions. The solar system, empty. Interstellar space, empty. The web, empty. The atom itself, empty. The universe is, by any honest volumetric accounting, a vacuum with rounding errors. And in that near-perfect emptiness, concentration is the miracle. Gathering is the rare event. Structure is the exception, fighting for existence. And there is no denser, richer, more improbable concentration of structure known to exist anywhere than the thing reading these words through your eyes. The universe is not a vast something in which you are nearly nothing. The universe is a vast nearly nothing in which you are, provably, spectacularly, something. Both truths from tonight are permanently yours now, and they do not cancel, they combine. You are microscopic, and the emptiness you are microscopic against is precisely what makes your existence the headline. Feel small whenever you need the relief. Then remember what the smallness is made of. 13 billion years of stellar furnaces, a ladder of dying suns, an ocean of quiet emptiness organizing itself just here, just once as far as anyone knows, into a being who could take this journey. The night sky is not looking down on you. The night sky, in the only sense that has ever been demonstrated, is looking out of you. Let us walk the ladder one last time, the whole climb, briefly, so you can feel how far we have come, and so the shape of it stays with you after the screen goes dark. We began with your hand, 10 centimeters, the only ruler you were born with. We stood on the earth, 17 days of driving around, varnished, thin sky, a world we have never drilled more than a pinprick into. We crossed to the moon and learned that every planet in the solar system fits in the gap. We met the sun, a basketball to our peppercorn, 1.3 million Earths of fire holding 99.9% of everything, and it was small, a dwarf among stars. We walked the basketball model city, peppercorns and coffee beans hundreds of meters apart, and learned that the solar system is emptiness with ornaments. We followed Voyager 50 years out, one light day from home, 30,000 years from the exit. We faced the gulf 4.25 light years, a basketball in New York and a basketball in Lisbon, 70,000 years at our fastest, to the nearest star that exists. We entered the galaxy, 400 billion suns, a 6,000-year count, a trillion worlds, 100,000 light years across, a city no member of our species will ever photograph from outside. We found Andromeda, a smudge your naked eye can catch, 2.5 million years deep. We rose through the local group, the Virgo cluster, Laniakea of the 100,000 galaxies, into the cosmic web itself, filaments and voids, the foam of everything, woven from dark matter we cannot see. We reached the sphere of all sight, 93 billion light years wide, walled with the first light that ever flew, holding 2 trillion galaxies and 10,000 stars for every grain of sand on Earth. We stood at the horizon and learned it is no edge at all, that the universe continues, hundreds of times larger at minimum, infinite at maximum, and that most of what we can see is already forever beyond our reach. and that we live in the brief, bright era when the truth of all this is still written in a readable sky. And then we turned inward and fell through the atom's stadium of emptiness, down toward the Planck floor, and discovered that the abyss below is deeper than the abyss above, and that you live on the middle floors of an endless building, made of the same emptiness as everything, moving at 2 million kilometers per hour while perfectly still, assembled from the ash of dead stars by a universe that needed 13.8 billion years and all those light years of room to make one of you. That is the true scale of the universe, as honestly as one voice can tell it in one night. Not a number. A ladder of broken rulers, and at the top and bottom of it, mystery without end, and in the middle, briefly, us. If this journey did to you what it does to me every time, if at any point tonight you felt the floor give way, that small, dizzy silence when a number refuses to fit inside your head, then I will ask the 3 things I always ask, and they take 10 seconds. Subscribe so you are aboard for the next journey, because this channel will keep going deeper, and some of what is coming is stranger than anything tonight. Press like, so the platform carries this to the next mind lying awake somewhere wondering how big it all is. And in the comments, along with your city and the hour on your clock, tell me one thing. Which rung broke you? Which single fact of tonight is the one your brain keeps returning to and bouncing off? The planets fitting behind the moon? The basketball in Lisbon? The 6,000-year count? The deep field in the empty speck? The 94% already beyond reach? I read every single comment and I build future journeys from what you tell me. So choose the one that is still ringing. And now, truly, the end. And I want to leave you exactly where we started, with your hand. Hold it up one more time in the dark and look at it. 10 centimeters. 7 octillion atoms, nearly as many as there are stars. Iron from supernovae moving through it with every heartbeat. Emptiness, almost entirely, arranged by 13.8 billion years into a thing that can hold a cup, write a name, touch another hand. Somewhere outside your window right now, the whole ladder is standing in the dark. The moon, the planets, the gulf, the galaxy, the web, the wall of first light, all of it real, all of it exactly as vast as we said, and none of it in 93 billion light years so far as anyone has ever discovered is watching tonight except you. The universe is very large, and you are very small, and somehow wonderfully, those turned out to be 2 descriptions of the same privilege. Sleep well.